Hi everyone, my name is Louise Capener and I'll be leading today's Computational Social Science Introductory Workshop. But moving on to what we're going to cover today, I just want to add a little disclaimer that this session is focused on introducing you to the concepts of computational social science. So we're not going to be covering more advanced topics, including, the epistemological and theoretical challenges posed by computational social science, nor are we going to be focusing on the ins and outs of one particular computational methodology. If you come for a sort of session on hands-on coding, that's not what it's going to be today. This is very much from the beginner perspective of talking it through what computational social science actually consists of. Although if there is a particular computational method that you are interested in, I really do recommend the workshops and resources that we have on different computational methods. Emma can hopefully post a link to our YouTube CSS playlist and also our GitHub, which has tons of repositories containing interactive coding notebooks and other materials. We have a bunch on text mining, for example, and some on machine learning. And, the same sort of tutorials can be found in the YouTube CSS playlist too. We cover a lot of computational methods there. For instance, recently we did a workshop on social network analysis. That's just gone up as well. So check out that if you want a real sort of, maybe after this, you're feeling like, okay, well, which computational method do I start with? Check out that playlist to get some inspiration. Okay, so what we'll be covering today is three main sections, which include, so the first thing we'll be talking about is what is up with computational social science. So what does this term even mean? What does it encompass? How do I become a computational social scientist? So what sort of skills am I going to need? Do I have any skills maybe from a sort of traditional social scientist background that I can build on? That kind of thing. And we'll also be going through the 8 steps of CSS, so of computational social science, which is where we'll have the most interactive part of the workshop and where you can get stuck in sketching out a CSS project for yourself. And of course, at the end, there's going to be time for final thoughts and any questions that you might have. So what is computational social science? It is the use of computational and empirical methods to address social science questions. So we can break this down a bit more. Computational social science, if we're thinking, in generalities, it requires sort of human thinking to identify important research questions. And because we're dealing with social science questions, we need to understand how people behave, what they want and what they want to achieve. So we need that crucial social science brain and that way of thinking in order to formulate those really interesting research questions. But we also need a sprinkle of more sort of computer thinking in order to then turn these questions into computational or empirical methods. So you're going to want to, try and think about how you can adapt your research question into something that a computer can understand and that you can analyze with your chosen method. After you've completed your research and your analysis, you're going to need that sort of human thinking, social science brain again to effectively communicate these results to other people. So another way to think about computational social science is to think about what it's not, because this can really help solidify it. Sorry, yeah, someone in the chat said what is CSS. I should really make that clear at the beginning. I will use CSS just as the acronym to refer to computational social science. So if I will use these terms interchangeably, definitely should have mentioned that at the beginning. So thanks for that, Sarah. I definitely should have mentioned that. So let's just go through a few points. So what is it not? So computational social science is not just using computers within a social science research project, nor is it just using digital versions of purely traditional social science methods. So, it's not just using SPSS to analyze survey data, right? And it's not just using digital, but purely non-empirical methods. So I will go ahead and untangle these a little bit because they're not always entirely obvious. So here are some examples that might help to put this into context a little bit. So one example of a CSS project would be collecting, processing, and analyzing millions of online news articles to show changing political attitudes. So you can see how we have that social science thinking here to formulate our research question about political attitudes, but also we have that sort of computer thinking that's inherent in using a computational method. So in this case, we're going to be using web scraping, right? That's our CSS method to gather a massive amount of news articles. We could also use real-time weather and traffic data to show how travelers react to things. So, for example, maybe you hear that there's a new storm that has caused damage to a local town. And what you want to do is you want to look at how people react and how this event is dealt with in real time. So you can see how this project isn't just a case of using a computer within a social science project, nor is it just a case of using a digital version of traditional social science methods. Instead, you'll notice that we have these uniquely computational methods. So we're using real-time weather and traffic data there. We have other examples which include, so you could, for instance, combine data from novel wearables or apps to establish correlation between, social media activity and heart rate. So this could be aiming to answer a social science question about how people feel about certain images. So you could look at how they react. Are there positive or negative feelings? Are they irritated? And so on. Finally, we could be interested in mapping family names over time by importing, processing, and formatting centuries of parish records. This could allow you to explore the movement of certain families, different areas. Maybe you could explore the changes in family sizes or whether, they moved away or not. So what I hope to do with this slide is just to show a few kind of broad, but really sort of textbook examples of CSS projects. So moving on, there are factors that make a CSS project computational. And the first of these is that you're working with, big volumes of data generally. Complexity, speed, difficulty, or novelty is going to be more important than the exact data source or type. So in our previous example of parish records, the source of data is not entirely important. It's about, the sheer volume, complexity, or novelty of that data. Additionally, the data must pertain to people, actions, behaviors, choices, and statements. And that links to the final point, which is that the research question should be a social science research question, which uses atypical data to talk about how people make decisions or what influences their behavior and choices. So the exact research question is not important, but yeah, the main point to stress is that it must be a social science question. And this is kind of where we have that really obvious intersection then between the computation and the social science. And that's what we're going to be focusing on today. So yeah, and just a little nice quote here. So in essence, CSS is an opportunity to do socially valuable research that would not be possible without computational methods and tools. So by this, I mean that, we couldn't, for example, manually scan years of police recorded statistics to try and understand how crime rates have changed over the last 10 years. This physically wouldn't be possible to do manually, or at least it would take, an extraordinary amount of time. But with the use of computers, what we can do is we can apply advanced statistics and certain models to understand this change in crime rates. So, we could use a computational method like machine learning. We can look at how we could count many types of crimes that are taking place in certain areas, and we could aggregate these crimes to map them spatially. We could make that map interactive so that when you hover over a certain area, you get some sort of statistical output. You could explore the long-term trend seasonality or the noise components of these different crime types. And this type of research just wouldn't be possible without the use of computational methods. Another example could be web scraping millions of online articles to try and understand how political opinions have changed over 20 years. In order to get a sense of those political opinions, we'd want to examine the words in articles and maybe how many words belong to different categories and what sort of themes are appearing and what the proportion of these words are and how that changes over time. And that's something that we wouldn't be able to do without a combination of computational methods, such as web scraping, which is methods that we use to gather a large amount of data from websites, and it wouldn't be possible as well without sort of natural language processing, which is where we use machine learning and text mining to identify and extract certain themes from texts and get a sense of those political opinions. So to see whether any of that made sense, what we're going to do is have a little bit of interaction and give you guys the chance to vote on whether you think a given project is a computational social science project or not. So if you'd like to head back over to Mentimeter, we can get this set up and then you can start voting. And we're going to talk through every example as well. So hopefully this will sort of help solidify some of those concepts that we've talked about. Okay, so I'll leave it a little bit of time for everyone to join. Maybe Emma could put the code back in the chat. Yeah, she has. So the code for anyone who doesn't know yet is 89891261. And you need to go to menti.com. So basically, I'm going to give you the example and you're going to vote on whether you think it's a computational social science project or not. So our first example involves a project where we want to scan historic recipes and use AI algorithms to recognize text with the aim of identifying ingredients and measures used over time. So yeah, is this computational social science or not? Okay, so it's interesting. We've got the majority saying that it's not CSS because there's not enough not enough social science there. Yeah, I would probably agree with that. So let's talk it through a little bit because I know that some of us have put different answers. This happens every time, and it's really good to sort of like talk through and get an idea of what this question is all about. So, firstly, I probably wouldn't expect people to say that there's not enough computation. So I know that some have said that, but so let's go through it. It does sound quite computational here because we're talking about the use of AI algorithms and scanning recipes, okay? So we definitely have a computational method being used here. We're using an AI algorithm, but I suppose an issue could be that, like 52% of you said, that there doesn't seem to be a social science question in here. So we're not really asking any questions about people's behaviors and choices. I mean, we could say that, you know, it's probably a CSS question, but I'd have to go with the majority and say that it's not social sciencey enough here because we don't really have enough information. It's not clear what that social science question is. We could be talking about how imported foreign foods integrate into domestic scenes and how people take that up. And I don't know, maybe it relates to wealthy people eating fancy foreign things. It could be exploring how that then trickles down and then these foreign foods become more normalized and accepted. So you can see how that would be a social science question, right? But if we're just talking about, I don't know, the proportions of natural foods that people are eating over time, that could be more of a, I don't know, a biomedical question. So yeah, this is one of those exercises where there is sort of sometimes no right or wrong answer, because it depends on how you interpret the question, right? So I would say that there's not enough social science sort of implicit here, but we can sort of think about how it could be if we built on that question a bit. Some of you have said that you need more information to decide, and that's absolutely fair enough, because like I've said, it could be if we think about the question in more depth. It could be that it is looking about, the adoption of foreign foods by, sort of wealthy people. But yeah, it also could be just a sort of biomedical question. So let's move on to the next example. So is this a CSS project or not? Is this a CSS research question? So we're using gamified smart home displays in order to understand how people interact with energy-saving technologies. So straight out of the gate, we have some arguing that this is definitely a CSS project. Some are saying that they need more information to decide, which is absolutely fair enough. I'll just wait a little bit, see if any of this changes. So yeah, we can have a little talk about it as well as the results come in. So personally, I'd say this one is looking like it's probably a CSS project. But again, as with the other question, I think it does depend. It's hard to capture the nuances of a research project in just one sentence. So it's hard to know what the purpose is and what you expect the conclusions to show. But I would think that a gamified smart home display ticks off that computational category in that we're capturing a lot of digital data. It's gamified too, so we're looking at sort of encouraging people to use this smart home display. There seems to be a social science question in there because we're thinking about how people interact with energy saving technologies. It could be looking at how quickly people react, or in terms of looking at what time of day it is that they're interacting with it, or who it is that's interacting with it. It could also act as some sort of tracking data, and again, that would make it very much a CSS project. So if the purpose of this project would be to try and change people's behavior to make them engage more with energy saving technologies, then that's definitely going to pose some sort of social science research question. So this is where we circle back to sort of how we conceptualize our thoughts and processes. But it is interesting to see that there's not as much division as compared to the last example, probably because the last example was a bit more vague in its wording. So yeah, let's just have a look. So yeah, there is a few that have said there's not enough social science, but I want to sort of draw your attention to the fact that we're looking at how people interact with energy saving technologies. So for me, that sort of definitely hints at some social science research. But not enough computation. Using a gamified smart home display, I would think that that's gathering a lot of data that would be very useful for us to analyze. And it's definitely computational. Okay, so let's go on to the next example. So what do we reckon? Is this a computational social science project or not? We're advertising for survey participation on social media, and we're going to store the responses in a database. So straight out the gate, some people are saying that it's not CSS because there's not enough computation. Some are also saying that it's not CSS because there's not enough social science. So yeah, very interesting. It seems that the consensus that's sort of building so far is that it's not CSS because there's not that sort of computational element. And yeah, I'd also probably have to agree with that. So if you remember on a previous slide, we sort of talked about how CSS is not just using digitized versions of traditional survey methods. There is no sort of clear line between how much computation is enough computation, but you have to ask yourself, if you can do your research without digital tools, then it's probably not a computational social science. If we draw the conversation back to surveys in itself, so typically the larger the survey sample, the more necessity there's going to be for computational tools because the analysis is going to become so much harder. But the use of online surveys doesn't automatically make it a CSS project, as you could probably collect roughly the same amount of responses through paper surveys as you would online. So let's see. Also interesting that 20% of you said that there's not enough social science here. And that's completely valid too, because we don't know what research topic this is focusing on. So it could just be collecting responses about participants' weight and height, for instance. And again, that could be similar to that first sort of question that we had on scanning historic recipes, right? Because we don't know what the purpose is of doing that, right? It's not specified in this question. So yeah, some have said that it's definitely CSS, but again, like whenever you see a question like this, you want to try and sort of like pick out a method or like a novel way of sort of like collecting data. Whereas if this is just, you know, using SurveyMonkey to get responses, you know, and store them in a database, there's not anything that's sort of jumping out there as a computational method. So I hope that does kind of make sense on that question. So yeah, this is the second to last project here. So if you're feeling like questioned out, don't worry, we'll be done with this soon. But this example looks at reading in real-time weather and air pollution data to create complex models of hyperlocal air quality. So yeah, what do we think for this? So quite interesting here. So currently it looks like the majority are saying that there's not enough social science here. Votes are still coming in, but we'll just have a little chat about this as they do. So yeah, we'd have to sort of, it's one of them, right? We'd have to know more about the question, right? So is it looking at a link between hyperlocal air quality and human behavior? We'd have to know, are we looking for political impact, or is there going to be an overlap between different research fields and schools? Maybe, I don't know, geoscience perhaps, or with physics. It's just not clear by this statement that there's an intent to explore human behavior. So I'd say I'd agree that there's probably not enough social science in this statement. But yeah, quite interesting to note that there's not as much division compared to the first example that we looked at. Some of you are saying that it's definitely CSS. I can understand in terms that we have that real-time weather and air pollution data. But you know, there's not an obvious social science question in there that jumps out, right? But we could certainly think about you know, cases in which this could be a social science question, but we would have to have more information to decide. So it's also quite valid that 8% of you had said, yeah, fair enough, I need to know more about this question. Okay, so let's go on to our last case. So what we're looking to do here is we're looking to train a neural network on social media data. And the aim of doing so is to create a believable chatbot that counteracts online radicalization. So what do we think? Is this a computational social science project or not? So if you're saying that we need more information, which is fair enough, but it looks like the majority so far are saying that this is definitely a CSS project. I think I probably have to agree with you. It seems to include all of the components of a CSS project, so let's go through it. So there seems to be an implicit social science research question here, as we're focusing on people's actions, attitudes, and behavior. So, you know, we're trying to counteract online radicalization. We're looking to cause a shift in people's sort of attitudes, beliefs, and behaviors. And we have a computational method to help us explore this. So we've got something called a neural network here, which has been trained on social media data. So for those of you that are a bit unfamiliar with this term, neural networks are a kind of artificial intelligence that teaches computers to process data in a way that's inspired by the human brain. So it's a type of machine learning process, also referred to as deep learning. And it basically uses interconnected nodes, or you could think of them as neurons, in a layered structure that resembles the brain. This is implemented in the hopes that we can then use it to predict a user's behavior based on their social media posts and messages. So in order to train this model, there's probably been as well a fair bit of web scraping involved, so very heavily computational stuff here. So for me, that would say big tick for the computational component. And I see that a lot of you, well, all of you have agreed because none of you has said that there's not enough computation in this. And I noticed that some of you have said there's not enough social science. So let's sort of cover that a little bit. Well, in order to counter online radicalization, we of course need to have good ideas about what online radicalization is and how people are radicalized and what kind of mental processes are going on. And we need to think about how people interact with each other as well. So looking at how we convince people to accept an idea or a question. So for me, I'd probably say that there's enough social science here. And if we just turn against the sort of the computational element, in terms of looking at, sort of methods that can be put in place to understand what people are thinking or certain themes that are coming up in social media posts, a method that's of use there is something called natural language processing, which we can use to get more of an idea about the breakdown of language. So if we're using these kinds of complex computational methods to then mimic and interact with individuals, that does seem like a clear example of computational social science to me. In fact, it's almost like a quintessential CSS project there. So yeah, I hope that's sort of like brought things home a bit. And so yeah, you don't have to do this if you don't want to, but feel free if you want to enter a few words about what you've learned about CSS so far from these slides, or maybe something that surprised you or something that you found interesting, or maybe anything that you're still curious about. Everyone will then be able to see your responses as they sort of like build up and flow through and creates a nice little word cloud. I can see that maybe what's happened is that some of you have probably gone off Mentimeter because I've said it's the last question, which is fair enough. We can just skip ahead. What do you want? You could put in the chat if you want me to just carry on. All right, nice. So complex data, yeah, for sure. Combined, so yeah, definitely you have this combination of social science perspectives, ideas, and then computational methods. Vague term, yeah, fair enough. It can be sort of difficult to know sometimes which, if a project is computational social science, it's an emerging field. So there is still quite a lot of debate about that. Social problems, yeah, so that social science element, web scraping, we've got some people that have put new technologies, yeah, for sure. Big data, so yeah, it's about, like we said, that volume of data, which some of you have said. Advanced method, varied online life, AI is coming up quite big, statistics. So yeah, thanks for everyone. This is just nice for me to get an idea of sort of like where we're at, maybe some things that I can then cover as we go throughout the webinar. So what I'll do now is, I know that some of you might not have had a chance to do that, but I want to know whether you want to take a short break. So sometimes people want to have like 5-minute break to sort of get a brew, stretch their legs, whatever. But sometimes I get a lot of participants just saying, oh, let's just plow on. So you can let me know in the chat if a lot of you say, oh, break, then we'll go for a 5-minute break. If not, we'll just plow straight on. So just yeah, just let me know in the chat. Okay, so let's carry on now. Hopefully you're all back. So we're going to talk a bit about how to become a computational social scientist. So first we'll start by covering what a social scientist is. So a lot of generalizations here, but social scientists are used to thinking like people. And what I mean by this is that they use a lot of human type thinking skills like abstraction, inference, the ability to understand fuzzy concepts and background knowledge. They generally don't shy away from grey areas or overlapping categories, as these are just part and parcel of being a social scientist. And it's no surprise that they need these skills because they study people, interactions, and behaviors, and this obviously requires a certain skill set. But it's important to point out that social scientists do build up a lot of data skills in the course of their research. So if you think about things like response categorization and coding, quality evaluation, pattern detection, and statistics in general. But whilst they do use computers, this often doesn't involve writing computer code. Traditionally, it might involve computer programs such as SPSS or Stata for statistical analysis. But like I said, typically not much code. And then we have computer scientists. And again, like I said, we're making big generalizations here, but in contrast to the sort of human type thinking skills that social scientists have, we can say that computer scientists, they're trained to sort of think more like a computer would. And the thinking skills that they have are more along the lines of concrete definitions and absolutes. So they have to think in terms of strict hierarchies and categories and clearly defined and scoped variables and rules. And in terms of data skills, computer scientists collect, analyze, and manipulate data through programming scripts, computational methods, and technological tools. But unlike social scientists, they're not usually taught to identify or motivate research projects on the basis of societal impact or value. Of course, sometimes this happens, but as a social scientist, this happens much more that, you might have to justify your research on the grounds that it will make the world a better place. It could be I'm researching radicalization in online forums to produce insights that could lead to countermeasures, whereas a computer scientist might be more focused on a more sort of logical justification for a particular project. So I want to make this algorithm more efficient so that it uses less memory. So in order to do computational social science, you're going to need a blend of social science and computer science skills. So you'll need the sort of human type thinking skills that we've identified, computer thinking. You're going to need to be open-minded, and you're going to need a mixed problem to work on. So let's delve into these categories a little bit more. So you're going to need those skills that we briefly touched on before. So those sort of key social science skills, so being able to identify problems or knowledge gaps, considering possible solutions, connecting problems to relevant theories or perspectives, and being able to collect relevant information and research to frame your approach. And like I said, these are all things that social scientists excel at. So the ability to understand context and nuanced perspectives, how to communicate abstract ideas, and how to attack a research question. Whereas this might be an area where computer scientists might struggle as they're more used to concrete definitions and absolutes rather than, like I said, those sort of more grey areas or murkier social science concepts. Okay, so that's the first thing that you'll need. Now we're going to cover why you also need those computer thinking skills. So computer thinking skills, what do you need? So you're going to need skills like the ability to access, organize, process, and handle vast or complex data. You're going to want to know how to write collaborative code, and also how to properly document your workflow, which is often a step that people neglect. These are all skills that computer scientists will find quite easy as they're trained in them, as well as data scientists who have been trained in computational methods. But for social scientists, it can be much harder to sort of transition from a social science way of thinking towards a sort of more computer science type way of thinking. Okay, so sorry, I've just lost my place. There we go. Yeah, but social scientists do have those data skills that they can build on. So again, that's things that I mentioned before, such as coding responses, pattern detection and statistics, formatting surveys. So, you're not starting from ground zero. You already have key foundational skills that you can then build on. So yeah, this is maybe some of you think it could be a bit wishy-washy, but I do think it's quite important because I can tell you as someone that has gone from a social science field to doing more CSS type of stuff, it can be actually quite intimidating at first, which is why it's good to remember that no one's going to start out with all the skills that you need, nor do you start out knowing all the skills that you might need to acquire. And this happens quite often. So you might start off saying, well, I want to scrape tweets for information on the 2016 US election. And you expect, okay, well, I might use some coding ability, but you might not know that this entails then learning about APIs or different file formats or ways to then visualize the data, right? So you often don't know what you're going to need to know. But main points to stress is that if you approach it with an open mind and a willingness to learn, you can definitely gain more skills. And you'll also start to understand that some skills are going to have a steeper learning curve than others. So it might be fairly simple to learn how to do a little bit of web scraping, to pull out every link on a web page. But learning how to build your own neural network and train it on a large amount of data might be a bit more complex. And this will lead you to hopefully collaborate with those from other fields. Finally, you'll need a problem that requires this combination of skills, okay? So that's going to be a mixed problem and one that requires that blend of sort of more social science thinking and more sort of computer science thinking. So some of you might be here because you've already encountered one of these problems, and that wouldn't be surprising because as resources become more digitized, these problems will become more relevant. As large volumes of data are being made available and they're updated faster, if you think about a classic social science problem, maybe we're interested in how men and women move through cities differently, or we narrow that question down to look at how people with disabilities navigate through city centres. Traditionally, for this kind of social science problem, you might station some interviewers in different places to stop people as they go past, or to count how many people go by that are using mobility aids, or you could send out surveys to people's houses. But now there's much more opportunity for us to gather a large amount of data with computational methods. So you could collect data from public transport networks about how many people bought tickets or swiped their card at particular tram stops. You could even get sensors which track how many cars go past a given point. Some of you that maybe are attending from UOM, so Uni of Manchester, might have noticed that these sensors are in operation on Oxford Road. So I think they track how many bikes go past. There's like a little counter that sort of increments up. So yeah, you could get sensors to look at how many cars go past a given point. You could use AI algorithms and CCTV cameras to identify how many people are moving through a space and at what speed. So as you can see, there are new ways of approaching traditional social science questions. And there's no reason as well why you have to abandon traditional methods completely. So part of good research is evaluating different methods and comparing outcomes. And it might be interesting to see whether by using different methods, you get different answers. And if so, you can then ask, well, why is that? Which then might prompt further questions. Sorry, I'm just checking everything's okay. Yeah, I'm just checking the Q&A stuff, just sort of have it in my mind for when we get to the end. Okay, so yeah, it can be a difficult task, but it has a lot of benefits in terms of building upon your computational skills and strengthening those social science skills that you might already have. So before we move on to the 8-step process, I've noticed that the last few times that I've done this workshop, a few people have said that they want to know more about a career path or, how someone finds their way to doing computational social science research. So I thought I'd just highlight my colleagues in my CSS team and their background. So you can see that on the far left, we have my boss, Jules, who did an undergrad in linguistics and then a master's in the evolution of language and cognition, then went on to do a PhD. We also have Nadia Kenar, who did criminology at undergrad and then did a research master's degree in criminology and social stats. Finally, I did politics at undergrad, then did a conversion degree master's in data science and AI, which was actually aimed at students from a non-computer science background. And I did that at the Uni of Liverpool, where I did my undergrad. And I'm not highlighting this to show, how amazing our team is, but just, basically to show that there's no one CSS degree, not yet anywhere, I think. I mean, there are some out there, actually. I've seen at different unis. I do think there is more sort of types of these degrees popping up. I know that the Uni of Manchester now offers a master's in social research methods and statistics with computational social science. But what I want to stress is that you don't need to have studied this at undergrad or for your master's to do a CSS project, because chances are your undergrad and master's or your PhD have provided you with really useful transferable skills that you can then use to apply to a CSS project. So you can see Jules on the left, she gained text mining skills and a knowledge of how to perform statistical analysis in her undergrad, and also learned about advanced stats and agent-based modeling in her master's and PhD. Meanwhile, Nadia, like many of us, gained skills in her undergrad related to traditional statistical software, then was introduced to the programming language R, which she then went on to use primarily in her master's. As mentioned in the previous slides, you don't need to be an expert coder to carry out a CSS project. After all, collaboration is going to be key. And for those of us who are students or academics working in higher education, we are lucky to have a big reservoir of potential collaborators to work with. So if you are new to this, consider reaching out to enlist a programmer or an expert on neural networks to help you with your project. But to carry out a successful CSS project, you are going to be expected to have some knowledge of programming languages like R or Python. And that's because these languages offer packages and libraries which will help you implement your computational method. So in our team, for example, Nadia is sort of our resident R expert. And some of you might have heard of R already, as it's becoming quite popular in the social sciences now. And it's been used for a while in other fields like biomedical science, biostatistics and stuff. So I will say that for those of you that have maybe previously used Stata before, or Stata, I'm never sure how to pronounce it, you'll find that basically it's quite similar. So it's super user friendly and it has a nice approachable layout. So you can see the layout for our VR Studio is on the left here. And what's really great about R is that you have the benefit of not having to faff about with sort of picking a code editor or a sort of integrated development environment, because that's all provided with R Studio. And it's also great if you're interested in producing data visualizations. It's a good choice for those that already have a background in statistics, as you'll probably find the syntax and the functions more intuitive. Whereas you can see an example on the right here of the coding language Python via Jupyter Notebook, which is just a coding editor. So in our team, me and Jules mostly use Python, and that's just down to what we were familiar with during our masters. So Python is more of a general purpose language, unlike R, and it's not just limited to data science. It has a really broad user base, and it's popular with all sorts of people, web developers, software developers, etc. But it's also known for its simplicity and readability. So what you'll find is the syntax is quite easy to pick up. But yeah, the downside is that unlike R, you do have to do some shopping around for what kind of coding editor you want to use. So like I've said, I'm not going to go massively into this side of things, as we are just on an intro workshop. But I would say that the biggest learning curve for me for getting into programming and computational methods was setting up my computational environment and learning basic code. So what I mean by that is, what I mean by setting up my computational environment is stuff like, how do I navigate my command line? What even is a command line, and how do I install software or coding packages through it? How do I write my first function in Python or R? And that's really why sorry, I was going to sneeze. That's why I spotlighted those code anxiety club sessions that were running twice a month. So I think I'd have to go back to the slide to see when our next one is, but I'm pretty sure it might be the 3rd of November, but you can check out our events page for that. And I do recommend that, if you come away from this and you're super keen about getting started on your coding journey or just setting up your computational environment, do consider coming along to those sessions, as they can be really, really useful. Sorry, I'm just looking at the chat. So is NVivo considered CSS? Probably not. It's more of a sort of manual tool, isn't it? But then I suppose it is sort of natural language processing. Let me have a think on that. Do you need R or Python for social network analysis? There is other software for social network analysis that means that you can avoid coding completely. So there's things like Usenet. So Sarah, if you're really interested in social network analysis, I've just done a talk on that last week, or maybe it was a week before. So you can check that out on our CSS playlist. But no, you don't need R or Python for social network analysis. Programming languages are really going to help if you want to get to grips with computational methods. But yes, there is going to be other tools that you can use to implement some of these methods. So yeah, Usenet's a good one for social network analysis. The only downside is that it's Windows based. So if you're a Mac user, you will need an emulator. And it's also not free. There is Gephi, which is free. You can use it both on Mac and Python, so that's good. But yeah, I suppose it is important to note, yeah, you don't need to know R or Python for some computational methods, but it is going to really sort of broaden your horizons if you do have it. Okay. Right, so let's carry on, because I know that we've only got sort of half an hour left. So before we take a short break, what I'd like to quickly do is sort of introduce an 8-step process for how to undertake CSS projects. So I did say we'd take a short break, but again, I am sort of tempted, to be honest, to just plow on, because we actually don't have a hell of a lot of time. So yeah, maybe disregard what I said about the break. So yeah, what we're gonna do now is go through this 8-step process. So David just said I have to leave for an online meeting. Yeah, no worries. I appreciate that, people have to leave at different times, and that's honestly no worries. You can catch this the rest of the talk, as it'll be uploaded to YouTube as well. So, if you need to go through it in your own time, that's no worries. So yeah, to make this process useful to you, I want you to start thinking about either a project that you'd like to tackle, or maybe just a research idea that you've been thinking about, or it can even be a project that you've done in the past. So you can jot this idea down, or maybe even put it in the chat. We will be having some Mentimeter discussion on it, so you can save it for then. But yeah, just have it in mind as you go through these steps. So this is the first step on your CSS project that you're going to need to consider. So you need to identify the problem that you're looking at. So you're going to want to be as clear and specific as possible about the pattern, problem, or lack of insight. You'll also want to identify who is involved, so where it is, etc. So yeah, and what this will do is it'll help you to define your research question. So maybe we have a goal in mind that I'll use the example from before. We want to get more people traveling actively through city centres. So maybe we want less cars on the road and we want more people riding their bikes or their scooters or just, being able to get from A to B in their wheelchair. So in terms of identifying the problem, that research question might be, what are the barriers to active travel in city centres? What you then need to do is identify who is involved. So you can start a list of who is involved, whether this is going to be potential companies that you're going to look at, people or different demographics that might be of interest to you. So you can really sort of hone in and make this question quite specific. So for instance, for my question, I might want to look at city councils, bus companies, different businesses in the area, vehicles, certain vulnerable demographics. And it's better to just go all out with these lists too, as it's going to give you lots of different avenues to explore. And you can always cross out any after you've done a bit more investigation into them or decided that they're not actually that relevant to your topic. The next step will involve exploring the problem. So this is where you'll gather information and perspectives in multiple ways. So you might use surveys, observations, or secondary data analysis, maybe some web scraping, expert interviews. So for instance, for my question, it could involve conducting a few interviews with people of interest. So I could interview the manager for my city's transport network or local council workers. But I'd probably also need maybe a survey or some observations or secondary data analysis to sort of capture how many people are actually moving through the city centre. So it's about using different methods and tools to further enhance your understanding of the research topic. You'll also want to spell out sub-problems, processes, relationships, simplifications, assumptions, related issues, etc. So yeah, basically after settling on your main research question, this is what I meant when I said you're going to need to get more specific in order to make that question relevant and measurable. So if my question is, my main question is, what are the barriers to active travel in the city centre? That might be my main question, sure, but I might specifically be focusing on, well, what are the barriers to active travel through this specific city centre at this time of day, given the way X, Y, Z, whatever. So this is the step where you really nail down the particulars of your research question. Okay, so what we'll do now is we'll switch over to Mentimeter for a minute, and you can feel free if you want to tell us a bit about what your step 1 or 2 might include. So no worries if you don't want to share it, you can always keep a note of it for yourself. You might just want to get some of your own research ideas flowing. And it doesn't have to be well defined. So I know it's hard to outline these steps if you've only got a vague idea, but for step 1, it could be as simple as people on Twitter from different political aisles really seem to hate each other. I want to look at political polarization on Twitter. And then your step 2 might be, I'm going to gain access to Twitter's API and see what I can find by scraping some tweets. And maybe I'll see how I can build a big data set. Of course, unfortunately, we can't use Twitter's API anymore because it's no longer free. But yeah, that's just an example of it. Maybe I should update. Okay, well, I don't want to spend too much time on this. So, okay, so the first example that we have is someone wants to look at what specific health/deprivation challenges do parents face in Northern Ireland. So step 2, I can use census 2021 data to explore this. So yeah, brilliant. So for your you've got your main research question, and then you're gathering sort of more information before looking at what sort of computational method you want to decide on. So you're going to use census 2021 data to explore this. And we've also got someone wants to look at behaviors on social media when working at home. Yeah, that would be quite an interesting topic. I wonder whether it's increased a lot since a lot of us now are remote and not at the office. That would definitely be a really interesting topic to look at. Okay, so let's move on now. So for step 3, what you're going to need to do is formalize your concepts. And what I mean by this is you'll want to make all the concepts and processes explicit, formal, and both computer and human understandable. So this is often known as pseudocode in the coding world, but you don't need to know how to write code. You just need to start understanding how to formalize things so that a computer could understand it. For example, maybe your research question focuses on trust, which is a very social sciencey sort of concept. If your goal is to get a computer to be able to measure trust or to model it or represent it in a simulation, you're going to have to think about how you'll define it in a way that a computer would understand. So, you could define trust as a variable between 0 and 100. You'll need to make rules about how that variable will change in certain situations. Maybe if two parties interact positively, trust increases, but then given a negative interaction where one of those parties is judged to be deceitful, levels of trust decline or then reset to 0. So what I mean by this is you want to start thinking about how to formalize concepts in your research question so that a computer would be able to interpret it. Okay, moving on to step 4. So step 4 involves collecting data, implementing software, and verifying your process. So you'll need to select and implement one or more methods. So many of you might have thought about these methods in step 1 and 2. So maybe you had a method in mind, like web scraping or agent-based modeling that you're going to do, or sentiment analysis. So this is the step where you want to implement these methods and make sure that they work in the way that you anticipated. So when you're implementing your computational method, maybe the data comes in a different format than you expected, or maybe you're encountering a lot of error messages in your code. So for this step, you want to look at whether you can make it work in the way that you expect. So maybe what you could do is you could use a toy data set, so a smaller condensed data set rather than your full data set while you fine tune your method. I often have to do that if I've got a hell of a lot of data and I'm sort of confused about where my code's going wrong. Often what I'll do is I'll sort of only use maybe a few rows of data so then I can see exactly where, I don't know, things are going wrong in the code. And of course, the choice of method is going to be highly dependent on the research topic. But lastly, you need to thoroughly check that the selected method has been implemented correctly. So that's what we mean when we talk about verifying your process or method. It's about answering the question, did we do the thing right? Okay, did we implement this method in the right way? So yeah, I will give you a chance if you want to talk about your steps 3 or 4 and what they would look like. Again, I know this might be hard as you've not actually undertaken the research or implemented any methods, but you can share any vague ideas that you might have. So again, I'll leave that up maybe for like a minute and then we'll head on just in the interest of time. So I think maybe what we'll do is we'll head on just in the interest of time. Okay, so at step 5, this is when you'll then experiment and analyze the data. So you'll run the experiments, build the models, analyze the data, or otherwise use the methods selected in the previous step. You'll identify and explain the results within the context of the experiment, model, or method that you've used. Then once you've run your experiments and analyzed the data, you can then start to interrogate the results and form some conclusions. So this means going beyond the experiment and the model or the method to draw some conclusions about what the results mean. So what sort of picture they're actually forming. So do you support policy recommendations based on your research? Is there anything that's sort of coming up? Like, is it pointing in a particular direction? Who or what do these results affect? Why does it matter? What should change? Who benefits from that proposed change? So, if we use that example again of looking at how people move through cities, perhaps you found that people with disabilities related to mobility have more difficulty navigating through particular areas. Maybe there's uneven surfaces or particular roads that are too narrow, in which case you can recommend some changes from that. Okay, so we are nearing the end of the research process now. So what we're gonna focus on now is on communicating and sharing your research. And in terms of communicating your research, it's important to understand that all of the previous steps must be communicated to multiple audiences in multiple ways. And what's really important is that you think about short-term and long-term engagement. And for a lot of us, from sort of like higher education or whatever, our mind might instantly go to, well, I want to get this published in an academic journal, which, sure, it's important, but it's also good to think about other forms of communication. So are you going to present your work at a particular conference? Are you going to submit a piece about it for a blog? And you can think about whether there are any workshops or classes that you could present to get your research shared more widely. And with that, you want to think about how you adapt your style and your tone of communication to suit these different audiences. So for instance, if you are writing it up in a blog that's like meant to be read by quite a wide readership, then you might want to sort of dispense with some of the complicated jargon and break things down in a more understandable and clear way. Finally, you're going to want to share, document, and validate your findings. So what we mean when we talk about validating your research is making sure that the right thing was done by allowing your work to be studied, reproduced, and or modified as needed. And to do that, you want to allow as many people as possible to be able to access your methodology and any code or data. So you want your research to be as transparent, well documented, and open as possible. And of course, obviously, there are going to be caveats to this. So you might be working with administrative data that is restricted. So you can look at workarounds for this that still makes it clear so people can follow your methodology. So you might create a dummy data set so that people can run your code and work through your methodology without it being disclosive. So yeah, this is just to stress that reproducibility is a really important part of research, and it is often neglected, which is why it's good to think about how you'll document your work before your research gets underway. So yeah, just from personal experience, don't save it all till last minute because it does become a bit of a nightmare. So yeah, just to note a few things at the end. So these steps are not linear, as there are many points from each step that you will need to return to or apply throughout the research process. For instance, documenting your research is something that you're going to want to apply from the beginning, like I said. And when it comes to computational social science projects, most or all are going to require many iterations, which means revisiting certain steps, okay? So maybe you'll come up with a research question in step 1, but after you explore the problem further in step 2, you might want to then jump back to step 1 to reformulate the research question in light of something that you've read. Or maybe you're on step 4 and you've implemented your method, but you need to then go back to step 3 because you've not outlined the concepts and the processes enough. And that's why, documentation is so important, just so that you can capture all these nuances and changes as your research evolves. I've often had it where I've made some really important changes to my code, but I've forgot to sort of document it. And then I come to writing up my methodology and I'm sort of struggling to explain why it is I opted for this type of algorithm or this particular coding package. So it is a really important step. And it's just, a good habit to get used to. So when you're sketching out your research question, note down why you think it's important. And what you'll find is that the research then, it writes itself a bit more easily, if that makes sense. When it comes to your code as well, good practice is often putting it in a code repository to protect it. And you can also put it in the cloud and make it available for others to look at, which is great because often when you've spent so long looking at your own code, it becomes difficult to spot issues with it. But then having a colleague look at it can be really helpful as they might be able to spot a problem that you've overlooked. So yeah, it's like we talked about at the beginning, it's important to be open-minded and remember that you don't have to know everything about computer science. You have to know just enough to be able to have those productive collaborative conversations with those in the field. So you may be able to reach out to someone that's more computer sciencey than you, who may want to collaborate on the code or another part of your project. So what I was going to do is, because we only have a few minutes left, is do some takeaway points, maybe do a word cloud. But I've noticed that maybe we're feeling a little bit done with Mentimeter, so we won't go there. We'll instead head to the Q&A. But these are the references for anyone that's interested, and we'll be making the presentation slides available, so you can always go back and look at these in more detail. But yeah, I'll just wait until I put in the chat that a lot of you are saying thanks. And I want to say thank you for coming, and I hope it's been informative. Like I said, I don't want to go too in depth and sort of technical. And also as well, I want to let you know that we have an evaluation that comes up when you leave the webinar, just a short survey. It is really helpful to me if you fill these out. So yeah, thanks for coming, and hopefully we'll see you again at some future talks.